Hello everyone, welcome to Try Rights, the new era of learning. Myself Sheikh Abdul Rafiq and I am your data science trainer. Let's move into the concept. Today's our concept is statistics. Okay? Data science introduction to the statistics. Statistics is nothing but science of analyzing the data. Okay, it is the method which we follow to analyzing the some data, right? When we have created a model of our prediction, we must access the prediction reliability, right? In this statistics we have another term called descriptive statistics, right? In this, first we cover some basics. Descriptive statistics, what are the count, sum. In previous section we had completed count and sum functions in numpy, right? Yes. After that, we have to check about standard deviation, average, and percentage. Okay. Now, once moving to the Visual Studio Code, we know all about the how to see the standard deviation term to how to min and max and 75% and the STD. So standard deviation. So this is code we have previously used. So once print we use function descript, right, for using the over the mode of the table. Let's run the code. See, here we can see count, mean, max, and min 25%, 50% of the data, 75% of the data. Like that, we have a task for statistics. We have a task. See what the task is. Data science. In data science statistics, we have static percentiles and static variations and static deviations, right? In that, one of the concept has we have static percentiles. Okay, in this we have to consider a percentiles, how much percentiles, like this we use describe function, but both of we can use another percentage. We have a function like describe, we can check overall table, how much getting 25%, 50%, or instead of 75% from the table, right? From there, a percentile which introduce a new function called percentile function, right? Now we use, now see, let's take a task. Find the 10% percentiles from the max pulse. So in this part, they're telling take 10% of maximum pulse. Okay, from maximum pulse we have to take 10%. We do 10%. For that we use percentile formula, right? Let's do it. Move to VS Code and take import panda numpy. We already imported, and now we have to take a variable called your wish. I take in PLS has maximum pulse has a variable. In that I have to enter which data from your taking, health data, for which you are considering for max pulse, right? Right. I'm considering max pulse. Okay. After that max pulse, we have to take the percent. We have a formula called NP percentile, right? NP percentile, from which you are giving percentile. I giving max pulse, how much you are giving the percentile. I'm assigning 10% of percentile. Okay, now keep into a variable as your wish. I take a percentage. I keep a variable in percentage. Okay, right? Now print the output percentage. Now see, overall the max pulse we has get a minimum max is 10%. Here instead of we have 25%, that instead of 25 we can see the 10% of the max pulse. Now see how much it getting. See 120, right? Now once check the standard deviation from the max pulse, it approximates around to the data. See 137 mean. Basically to reach has to 25% is actual of the mean of the max pulse. See, directly assigning the mean. How much is 25%? 30%, right? 130.000. It's 25%. In 10 to 15, we have 15% less, right? So it taking directly mean value. It is nothing but average of the table, right? If we start from the 10%, right? The overall table in 100%, least is the mean and highest is the max, right? From the least what starting with the 10%, so it considers 10%. It directly assigned to the average of the mean 120, right? And now see the data. Now check. Now I think I hope you all understand about the 10% percentile function. How could you use? Instead of this, we can use like why should we use 10%? We can calculate how much 45% to. Now run the program. Now see 45% is 140, right? If predicting direct max pulse is 45%, it's getting range between the 140, right? See, it's present the approximating rate range, right? Now moving to the next statistic method is called static standard deviation. It is one of the most important concept in statistics to find the how the spread of the data, how spread overcome the data, right? See, once in this we have a lower and higher. So a lower deviation means that most of the numbers are close to the mean, which is close to the mean. See, in this range, most of the closest number it represent. Otherwise, it represent the highest standard deviation means that the value are spread out over a wide range in the max range. Okay. Now in this we use std for std is the function. Std bracket is a function. From this function we have to measure, we have to take the data, calculate the data as standard deviation. Okay, we want to represent the output like this. See, duration equal to 42, average pulse is a 14, is a overall standard deviation of the overall table. Okay, we in descript there's a little bit difference in descript and STD standard deviation. It represents the overall table, but it represents the only one single row of STD, right? In the term STD, it represents that. Okay. In that, we also check one similar difference, right? It is so tricky. You can understand when you see the output. See the duration time, 42. Okay, wait. I execute the code and I will show you. Let's keep this code side. I'm keeping the describe function till the this code end because you get some more clarity about the function, what happening in the script and what happening out of the function of standard deviation. Okay, now put the standard deviation into the picture. It takes the closest range, right? Instead, first I write the code, and when the execution, I will show a little bit diagram in diagram you to understand better. Okay, the input numpy. Now what we do, standard deviation, right? Take the standard deviation as NP. We given a for numpy is given a for functional SDT, right? And which you are taking health data, right? I'm taking health data. Now put into a variable STD. I'm taking STD as a variable. Now print STD. Okay, after the printing, I will show you one small example. Then you can understand better, right? Once see here, duration is takes STD has 9.2, right? See the here duration is 9.2. It takes the lower range, right? It takes the 9 point has lower range. Once see the average pulse STD, it approximately takes 15. But here we take little bit difference in the number on the range. Max pulse has 11.35. Here say max pulse has 10.35. Taking the lower range. Here we also read the data. Here also we read a lower standard deviation means that the most of the number are close to the mean average. It predicts the value between the range, in range between the nearest value in mean or a wild range in max to spread the data, right? For example, I explain more clearly about it. Let take I explain drawing pad. Let take I have a wild range, right? I have a wild range. Okay. For a wild range, I take has starting has 1 and ending has 2, and I have the ending has 10, right? Let me assume we have some data, like is the middle of the data has median has 5. Okay, from this between range we have to 2 or 3, right? in that up to 1 to 4, and here 6 7 8, right? 6 7 8, and here 9. Let us assume a data. What data we want to assume? We assume a data has, let us take, we have a 1 lakh children. Let's take assumption, not as in a true example. Just take assume we have a 1 lakh children. Okay, instead of 1 lakh, they up to 4 to 9 years they are in primary standards, right? They are studying in primary standards. Okay, 4 years to up to 9 years to children were studying in primary. Okay, is 1 2 in the difference of this range. What in the difference of this range, 1 to 3 were not started the primary, and here the between of 9 to 10 they already completed the primary graduation, right? In the range we have to calculate, here we can say in the range between we have 15,000 students, 15,000 children we had not started the primary educations, right? 15,000, here the range we can say 15,000. In between here we can say 5,000 members or completed the primary section, nursery, LKG, like we take, let us assume the data like that. And I telling this because I want to explain more clearly about the what the standard deviation range expects from higher to lower, right? Okay. Instead of 1 lakh, we had minus 15,000 and minus 5,000. It did have we have 80,000 data, 80,000, right? 80,000. In this 80,000, we have who are presently pursuing the primary education, right? In it, the middle value has that the middle value is 5, is considered as a range, as a lower range from the mean or a higher wild range to the max. You understand? It's take the approximate value nearby the lower than mean or a wild range from the higher value or lower value. Right? You can now understand. I think you understand now. It's see here lower range, a lower standard deviations that most number are close for the mean average. A high standard deviation is the value spread over the wild range, right? See, is spread over the wild range. Okay, the nearest value it be takes. Now see the output. It's also take like that. No, see in duration it takes 10, and here we takes 9. Like that, the data will calculate. Okay, now you understand. Now in this concept, we have another concept as we want to find the coefficient, right? We want to find the coefficient of variations. For that, we have a mm, formula, coefficient of variance, right? Coefficient of variance, right? Coefficient of variation. In that, we have what the formula has. Let us carry latest coefficient. Okay. Okay. Wait. I want to comment this section firstly. Okay. Coefficient, right? Coefficient of variation. Instead of this, I copy it. It's taking time to type. Okay. Now, equal what we want to calculate, mean, standard deviation. Standard deviation. We want to calculate the standard deviation first. After that, we want to buy with mean. Okay. This is the formula. This is the formula for we use for find the coefficient of the variation. Let's find the variation like this same code I am converting into this variable as coefficient as variable, and here I converting data as mean np dot. We take mean function. We already known about that mean, which mean for which health data, right? We take a health data for it, right? Now change the output COV, right? Now see the data. It gives the coefficient of the variations. Now see it's approximately gives a 0 0 0 0 0. Okay, it is a coefficient of the variance of the data of average pulse and max pulse and calorie burnage, right? Now see, now see here, this is the output we want expect we expecting, right? 0, 0, 0. See, the coefficient of the variations is used to get an idea how a large standard deviation is mathematically. Okay, the coefficient of the variation is defined. See the formula. It is to little bit of how the large data will spread the lower than area, right? That one now. Another concept we can introduce, it is nothing but statistics, right? Statistics variations. It is the concept of we can here we can grip the concept because most of the cases we use statistics method most. So we learn these functions, right? Now the concept of statistics variation. It is nothing but another number that indicate how spread out of the data. Okay. In fact, you take a square root of the variance, it gives 2. If we take a square root for the static variations, it gives a standard deviation or it gives a variation, only variations. Standard deviations only get a variation, standard deviation or a variation by doing the square root of the variations, right? It involves the 4 steps. It involves 4 steps. What are the steps? Step 1, calculate the variations, find the mean, right? Step 2, for each value, find the difference from the mean, right? For each difference, find the square value. The variance is the average number of the those square root values, right? Now, I think you don't get my point. While doing the code and mathematical practice, you get some knowledge on it. Okay. Instead of doing code, we have a little function for this. We practice roughly on code. Roughly, we can practice. Okay. Roughly, we can practice. It's better to understand you more. Okay. Instead of function, I use code. Okay, I use to how to what is that I can tell you. Okay, now steps involved. What are the steps involved? See the step one. What are the steps involved in it? See the step one, calculating the mean. Calculating the mean. Okay, now take it. Now we want to calculate the mean, right? We want to calculate how we calculated the mean means sum of the digits by average, right? We can calculate easily. Now see the graph where the data over here. Yes, see. We want to calculate. Let us take a average pulse or mean pulse. We want to calculate about it. Let us take average pulse first. See here, data is 80, 85, 90, 95, 100. We want to do sum of those all digits and divide it by 10. Then we get the mean of the average pulse, right? Now, where our code has statistics, right? Here we want to do the sum of those all numbers, right? What are those? I want to calculate a 80 plus 85 plus 90 plus 95 plus 100 and plus 105 plus 110 plus 115, sorry, plus 115 plus 120 plus 125, right? The whole sum, we are the whole number we want to do the sum digits. 82 sorry, 82, it has only taken 150 120 range, no, not 150. It considers only up to 120 or 125 it considers. So we want to take the up to 120, 125 value, right? 125. Now we want to buy with 10. Okay. After that, we can get the mean value. After by doing this calculation, we get the value of 102.5, right? We use calculator instead of the doing this process, and now calculate the step 2. We find the step 1, we find the mean. Now we want to find the difference from the mean. Okay, we have to find the difference from the mean, right? Now take consider as step 2. It is step 2, to find the difference between how can we find the difference from the mean. We get the value of 1 or 2. So this value we have to consider as minus with this those all values up to 125, right? Let us see, we understand about it. Let us take a pretty and that. Okay, now I hope you will understand now. see, instead of mean, we comparing the both values which has over value. With that we have to compare and minus the value, then we get the difference of the mean value, right? Now 80 minus how much we get the value, 102.5, minus it, how much we get. At the last I will define you what we get. Now take the value, take the inputs, we have to take it, right? Now change the values. Here we take 85, here we take 90, here we take 95, here we take 100, here we take 105, here we take 110, here we can take 115, here we can say 120, 125, right? It has the values, and now calculate those values. We get from minus range and up to positive range, right? We get the range from positive, or to get range start from minus, right? The higher number is 1 or 2 now, the range will be definitely with minus, right? I has already calculated. If you also do practice this mathematical equation, and once you want to practice by mathematical, not by using function, by using hand practice, you want to do this calculation to find the variation. It is helpful to you to understanding a better what the behind the scenes, what the process is working for the var. So variation in the variation concept in statistics, right? You can understand better then. Okay, I want it get 22.5 minus 22.5. This get minus 17.5, and for this I get 12.5. For this I get 7.5. For this I get minus 2.5. Okay, now the range of 100 is getting positive value, same as now 2.5, 7 point, sorry, 7.5, now 12.5, now take has 17.5, now 22.5, right? This is a we can now we find the difference. From which we find the difference? From the mean. These are the difference. Those are the difference, right? Now, what's our step three? Step three is find the square value. Step three is what? Finding the square value of the variance, right? Now, here take the what's the step three? Finding from which we are finding the square value. Instead of any value we take, we just want to sum, not this already we consider one or two, we consider as finding the difference from the mean. Now we have to do the root square for this given outcome value of the finding the difference from the mean, right? For this we have to calculate the 22 square whole square to 17.5 square. We want to calculate the value like that, right? Okay, now let us take. Okay, now take the value. It takes I think 22 by 7 I take. Now what is the first value? 22, right? Instead of 20 minus 22.5 square of 2 I have to calculate, right? I'm taking the variables here. I have to calculate the variables here. Minus 17.5, right? Here I get 12.5. Here I get 7.5. Okay, 7.5. Here I get only 2.5. Now here also positive 2.5. Now after that I get so positive 7.5. Right. Now 7.5. Now 12.5. Now calculating 17.5, and we want another sum. So I'd say now we want 22. Right. We get all this. We want to do square of the all these values. Right. And for the first value we got 5.6. Sorry, 506 by 25. For the second value, we get minus 3. On doing the square function, all the minus functions get into positive, right? Minus will not probably be defined, right? Minus get cancelled, right? By doing the square of the for every digit. Okay, now take 306. Sorry, not here. it is a value from the 7 doing the 17.5 whole square to it is the answer as 306.25, and for the 156.25, for this 56.25, for this 6.25, this also we get 6.25 because the value is nearby 100 near to 100, right? Okay, now again 56.25, again 156.25, again 306.25, again 506.25, right? Those are value we has get. Now we also consider step 2. See, once we find the mean, okay, we find the mean. How by how we find the mean? Sum of the doing the all digits by 10, we get the mean of the variations, right? And by the mean value, we find the difference from the mean, okay? And step 3, we find the square value from the outcome value of the difference of mean, right? Now, what the step 4? If is nothing but average. We want to again find out the variance average number, those square root values, right? Now again we want to find the square, again we want to find the square value, average value. Average value is nothing but it is also mean, right? It is also mean. It is also called average is nothing but mean, no? Mean, no? So we also here also same process. Where the step in step 1 what we did, sum of the origins by 10, we get the mean. Average is nothing but it is also a mean function, right? Now do the outcome values, we have to do the sum 306.25 plus 306.25 plus 150.25 plus 56.25 plus and 6.25 plus again 6.25 plus again 56.25 plus 156.25 plus again 306 plus 25 again 506 to dot 25, right? The whole value we have to calculate, right? And then we have to do the by 10. It's get the value of, okay, I write the value here, is more visible. I equal value I has get the value has, I get value 206.25 is the overall value I get from the method. I follow the 4 steps and I get the method like this, right? 206. Okay. Now, okay, let's keep the data, right? And let's keep the data. Now we can now directly by using function we find the what is the actual value. Okay, in that we have only one function. Here take has data. I'm changing var. Now instead of std, we take the var function. In nothing but is the function help to find the variations of the statistics. Now see, now run the code. Now we see the data. Now see how much does average pulse get in calculation. We get, see here, 206, right? By doing the 4 steps, I want to know what's the process is running behind the var function, the variation concept. So to understand better, I do this all mathematical calculation to easily understandable for you. So this is like this we can find the variation, standard variations. Okay, okay, guys. I hope you understand well.